All right, so let's look at remove and insert here. So I'm going to do a couple adds. I'm going to do 4 adds, and then we'll do a couple inserts. So start. So we're going to add L to the list. All right, and we could work. Oops, delete that one. And add J to the list. So again, head is not null. Current node is equal to head. If current dot next is equal to null, oh, that's where I would add it. Let's add in J. Let's add in D. Current is equal to head. If current dot next equal to null, current is equal to current dot next. That one is null. Add in D. All right, so I want you to keep thinking in terms of algorithms here. Even though you know exactly where to put it, if you think in terms of the algorithm, that'll help set that in your mind. So is the head equal to null? Nope. Current is equal to head. All right, so we're going to loop through this. So we could loop through this using a while loop. So while current.next is not equal to null, or we could use it doing a for loop because we know the size. We can just loop through the size because we can get to the end. So for current dot next is less than size, current dot next is equal. I'm sorry, I is less than size, or let's just say current dot next is not equal to null. While current dot next is equal to null, okay, well, not equal to null, current is equal to current dot next. Not equal to null, current is equal to current dot next. Oh, it is equal to null. Add in L. All right, so worth repeating that. I know we're not really looking at add here, but worth remembering it. So insert value D at 1. All right, so we need to find value 1. All right, so we know value 1 is here, so we can do 4. So we check, is the insert less than 0? And if it's size, then I just add it in right away. If it's equal to size. If it's less than size, I'm going to insert it somewhere in between there. So I can say current is equal to head. And for, well, let's see. So if I say I is less than index, then I go and I point to this one. So current is equal to head, current dot next is here. Well, if I go to here, well, this is where I want to insert the value. So that's a little bit problematic because how do I insert a value right here before itself? I can't do it before. So really when I'm doing an insert, I don't want to find the node, I want to find the one before the node. So I actually want to go to find not 1, but I want to find index minus 1, in this case 0. So at that point in DSVisualizer, I can hit change next. And then I could say insert new. So after this one, I insert new. Now, inserting new adds a node here, but it's not linked up yet. So I know this is going to be node D, but there's a couple other steps that you're going to have to do when you write the code. So the new node you add, the next, well, in this case, I know it's going to be this one. But now if you see my linked list, there's 2 of them pointed at that one. So I actually need to change the current that I was pointing at to point to my new node as well. Now, the order of those don't necessarily matter, but really it does matter from the standpoint I don't want to lose that link. But again, there's some way I need to go set this up. So the way I did it is actually the way I do it in code, is I set the next first, and then I point this one's next to the current, so that way I don't accidentally lose my link here. And you'll make that mistake, I'm sure, at some point in code. But let's check it out. Yep. See, I inserted it in. Makes perfect sense. So let's do another one here. Insert at 3 now. Okay, so this is where we are going to loop, but we don't want to loop to 3. We want to loop to 2. So index minus 1, because that's where we're going to insert it into the sequence. So head not null. The size is greater than 0. However you want to check it. So current is equal to head. So for index I is equal to 0, I is less than index minus 1. So current is equal to current dot next. Current is equal to current dot next. So 0, 1, 2. We go here. And we're going to change next to be inserting a new one. And the value we're putting inside of there is P. All right. So now the new node dot next is equal to the current node dot next. Right. So we're going to link the inserted node to where the old one used to be. And then the current node dot next is equal to the new node. So I hope it's pretty simple here, and I hope we can see in DSVisualizer how that sequence comes about. And so I hope you can play with it here. And again, think in terms of the algorithms. Think in terms of the node. What does the node know? Well, you only deal with one node at a time, and all it knows is its value and its next. Now, I can also know the next, but I don't necessarily want to go beyond that. And that next is important because let's talk about removing. So let me add in 4 values, and then we'll do 2 removes to see how that works. So let's start here. So adding B, I'm just going to do this quickly. Add M, add A, add F. So now it says remove the item at index 2, 0, 1, 2. Again, if I want to remove this item, I can't have it remove itself because it's the one before that links to it. So if you picture what should happen here, if I want to remove an item from this list, this linked list, the one before it is just going to simply point to the one after it, and we're taken care of. All done, all clean. So how do I do that? Well, again, I want to, just like we did with insert, I want to navigate to index -1. So I'm going to check, okay, well, the index is not negative and it's less than the size, so I can use my for loop here. So current is equal to head, and for index I is equal to 0, I is less than index -1. So 0, current is equal to current.next, current is equal to current.next. A is the one before, right? 0, 1, 2. I'm sorry, M is the one before. 0, 1, 2. This is the one I want to remove, A. So M is the one before. So I want to change this one's next to be over here, which is m.next.next. So m.next is equal to m.next.next, or current node, I should say. Current node.next is equal to current node.next.next. Right? Makes sense? I'm going to skip over that. I'm going to save that. Now let's see if that's what it wants. Yeah, that's exactly what it wants. But now I have this ugly thing in the middle. So this is a little DSVisualizer thing. So in Java, eventually this will get cleaned up on its own. You don't necessarily have to worry about it. But I'm going to make you worry about it here because maybe you're going to do C or something someday. So I need to go and delete this node on my own. There's literally no way to do it in Java. But in C, you'd actually do a deallocation, if you will, of this memory. You'd free the memory to be more accurate to the syntax. And then I can confirm the delete, and then it goes away. Okay, and then we go to the next. Now, you don't have to do that, but you can. Now, again, if you need to delete the last one, you just stay clear next, and it deletes the last one if you ever get an index that is the last one. But in this case, we're moving item 0. Well, when we remove item 0, if we see the index is 0, we have to be aware of the fact that that's the head. And so if we get that, it's kind of easy because if it's 0, then we just change the head. So we say change next. And again, it's head.next is equal to head.next.next. So I pointed that one, save it, and just validate it. Yep, that works. And then I'm going to go clean up that node, click that, and get it out of there, and I'm done. So remove is pretty easy in that you only have to change one thing, and it kind of poof disappears. But again, you have to remember to navigate to the one before. All right, so don't forget that once you get a good feel for these individually, you can just do a generate random. And when you do a generate random, you can add to it if you want to, and you can generate more than 10, but to get the points, you need to do at least a certain number of 10 sequence lists to get it all up and working. And so I'll leave this to you to go off and play with, but I just want to remind you and encourage you that, don't do some focused learning, do some stuff where you pay attention to individual topics and practice those individual topics, but then also just practice it in some sort of random sequence so you really test your knowledge in that extra different way. So again, I'm just kind of doing this by hand, and I can do it intuitively, so I know that, well, this is 2 and I can change to F, and that should be cool. But also practice your algorithm, walk through it. So so eventually, I can do these even while talking about it, and that makes it really easy. This is making a really easy one for me. Insert value Z at 0. Well, change next. Insert Z. Change next. to there, change next to there. So again, intuitively, I know what this is supposed to look like. And that's helpful for me to debug it because if I can print this out later on, I know what the sequence should look like. I know what the next and values should look like and whatnot. But it's also important to practice the manipulation of the variable, the algorithm directly as well. So again, you don't have to ever finish these sequences, but it's always helpful to go off and be able to do that. If you stop early, hit the reset button because that makes sure that your progress is saved as you're going about it. If you just close it, it won't save the progress of where you got. But if you want to get the most progress, hit the reset button. But again, or complete it, make it all work. If you mess it up, just hit the reset button and just do another one. If the tool breaks, just hit the reset button and do another one. If the tool freezes, come inside of here and hit the X button and it will make it go away. So I hope you have fun with DSVisualizer. I hope it really gives you a better feel for linked lists. And if you have any questions, let me know.